Okay, so we're going to go over the Chapter 3 review guide. I uploaded the PDF too, so you guys can just look at the answers, but I want to explain some things. So the first section asks, is it a function? So we know it's a function if our x's are not repeated, which means our inputs don't have more than one output. So we're good on functions, but if we look at 1, we have to check that rate of change. And it's 5, then 6, then 4, so this is nonlinear, it's not constant. Okay, 2 is good. For 3, you have to solve for y. So once we solve for y, we get y equals 7. Okay, this is that horizontal line that we learned about, and this of course is a line, so it's linear. For number 4, when you solve for y, you have to divide by 2x. And when x is on the bottom, it's nonlinear. Whenever x is squared, cubed, to some power, it's nonlinear. Whenever there's a square root in the equation, it's nonlinear. It has to be our usual x plus b, mx plus b. So for the domain and range, you should know that domain are our x values. So if we're looking at domain for 5, what is the interval of x values being used? We didn't get to talk about this much, but these arrows means that this graph is going to keep spreading out further and further and further, and it won't have an end. There'll be no end, so it'll be all real numbers. It'll go from the farthest negative to the biggest whole number, and it's never going to end. And then its range is its y value. So if you look down here, the smallest y is 0. So that's why we have 0 for our range, y in the middle, and since those arrows are pointing up, they're going to go on forever. We have infinity on the right. Okay, and these are intervals. They're never ending, so it's continuous. If you look at 6, we have actual points. So when you have specific points, that's discrete. Those are specific numbers. So you have to list all of those points and pull out all of the x's for domain and then all of the y's for range. 7, 8, and 9, you guys were all pretty great at. All you're doing is plug it in. -3 for x, -2 for x, and 1 for x. Okay, to find x and y intercepts, what you have to do is plug in your zeros. So for an x-intercept, y has to equal 0. So we plugged 0 in for y, and then we plugged 0 in for x, and we got our x and y intercepts. And we did that for both of them. So you're just plugging in 0 for the correct value, and then you're solving. Okay, so now we're on to graphing. So for 13, that is in standard form. So you have two options. You can find your x and y intercepts and just graph those. So it's the same steps as the ones before. Plug in 0 for x, then you get y-intercept, which is 0, -3. Then you get your x-intercept, which is 9, 0, and you can graph that. Or you can go over here and you can solve for y, and then use slope-intercept form. So after we solve for y, we know our slope is 1/3, our b is -3, our b means our y-intercept, so we go down here to -3, plot our points, then we go up 1, right 3, and that would be your line. 14, you're just finding your slope and your y-intercept. Okay, so 15 and 16, they want you to tell them what the slope is. So they give you a table. So this table has groups of ordered pairs. So our first one is 1, 3. And then our second one is -4, 3. So all you have to do is label the first set x1, y1. Second set x2, y2. And then you plug it into a formula. Okay. What's important is that you pay attention to these signs. So we have -4 as x2. -4 is written down. Okay, for 15, our slope is 0. For 16, we plug this in. We remembered to keep this negative sign, and we got 3/2. Okay, for 17, 18, and 19, there's a few different ways you can do this. They want the slope, y-intercept, and x-intercept. So you can plug in your zeros, and you can get your x and y-intercept. Or what I did was I just read 17, found m, which is -1, that's our slope, found b, which is 3, that's our y-intercept, and then I plugged in 0 for y and got our x-intercept. Okay, then for 18, I solved for y to find the slope. So I added the 3x to the right side, and then I divided by 5. Okay, when you divide that right side by 5, you have to divide each piece. We end up with 3/5 x minus 6. Then I just found m, b, and then plugged in 0 to find our x-intercept. And for 19, x equals -3. So we know that if x equals -3, we're going to our x-axis, marking our dot on -3, drawing a vertical line. And that slope has rise, has no run, so when there's no run, it's undefined. And of course, there's no y-intercept with that graph. Okay, now these last 3, there's only going to be 3 on the test. And I'm going to tell you what I think is the simplest way to do this. So you're going to get a new rule, g of x, r of x, and q of x. And you're going to apply that change to the function and then just graph it how you normally do. So for 22, we have our parent function, 3x plus 1, which is f of x minus 4. So I just stuck that minus 4 on the outside, combined like terms. I got 3x minus 3. I found m, which is our slope. I found our y-intercept, which is b. And all I did was plot the y-intercept, go up 3, right 1, and now we have our new graph. Okay, this pink one is the parent function. And just for our sake, here's this point on the origin. -4 means a vertical shift down 4. So all we're doing is 1, 2, 3, 4. Look at that. Our line shifted down 4. All right, for 23, we have an x minus 2 on the inside. Okay, that's a horizontal shift, and that is with the x. So what you have to do is substitute. So I'm going to take our original function, 3x plus 1, and where that x is, I'm going to sub in x minus 2. Okay, so what's our first step here? We have to distribute. We get 3x minus 6 plus 1. We simplify, then I find my slope, I find my y-intercept, and I graph. Okay, 24, we have a -4 on the outside of our function, so that's exactly what I did. I put it on the outside of the function, I multiplied and distributed. I found my slope, which is -12/1, and b, which is -4. So I plotted -4 down here, and then I went, there's 2 ways you can do this. You can go down 12 and right 1 because it's a -12, or you can put the sign on the bottom and you can go up 12 and left 1. As long as one of those numbers, whether it's rise or run, is in a negative direction, then you'll have the correct slope. So I went up 12 and left 1. You can go down 12 and right 1. Either one is correct. As you can see, our negative sign did that reflection rule. It flipped our slope, our line in the opposite direction. And then the 4 stretched it. Stretched it to be much wider. Okay. So if you want to practice these again, let me know how you feel about taking the test today. If you need me to make another video, that's fine, but your test is going to be almost exactly this review. All right, good luck.